Evening. Hello, everyone. Thanks for coming out. It's been a while since we've been able to do this in space together. So it's great to see you guys here. And yeah, it's my pleasure to get the lecture series kicked off post-COVID in quotes. So for those of you who don't know me, my name is Jason Young. I'm the Dean of the College of Architecture and Design. And I'm going to be introducing Katie and Kyle, who for some of you don't really need an introduction because they were here for a year teaching here and working with students. But nonetheless, it's always fun to give a proper formal introduction to people that you may think that you know well already. So tonight's lecture is presented by the Robert B. Church III Memorial Lecture Fund. For more than 45 years, the Church Lecture Series has brought world-renowned and provocative lecturers to the college. We thank the church family for their generous support of our college and for making this kind of exchange possible. Without their support and support from people like them, we would not have the opportunity to enrich the experience for students and faculty alike. So it's a real privilege for us to be able to do this sort of programming. So tonight's lecture is the culmination of the 2019-2020 Tennessee Architecture, something Katie and Kyle held jointly that year. And it was a year in which the previously unthinkable happened, where the pandemic forced all of us to go from what we knew well in terms of a format of working together into a completely online experience. And as a result of that pivot, the work of the fellowship also became a bit of an endangered species, if you will. It disappeared radically from our view, but it didn't disappear from Katie and Kyle's view. And in fact, it reappeared in the fall of 2020 at the Knoxville Museum of Art in a kind of curious re-emerging of their project installed in one of the outdoor terraces at the Knoxville Museum of Art. So even though we lost sight of the work, they didn't lose sight of it, and I think that's to their a testament to their fortitude and tenacity in their research. Hopefully you've had a chance to get a glimpse of the exhibition that's installed in Gallery 103, which is right across the atrium. That exhibition, along with this lecture, is the typical way in which we would culminate a fellowship here in the college. So they've mounted that in the last couple of days, and that will be on exhibit through October 22nd. So check that out. So, all right, now to the introduction. Katie Mcdonald is co-founder of After Architecture and assistant professor of architecture at the University of Virginia. Katie prototypes new biomaterial assemblies with the aim of creating building material systems that sequester carbon and reduce construction's contribution to the environmental crisis. She holds a Master of Architecture from Harvard University, GSD, where she received the Paul M. Heffernan Travel Grant and a Bachelor of Architecture from Cornell University. Her professional training includes work in the offices of Mall, Stainer Architects, Morphosis Architects, and Lorcan O. Herlihy Architects, mostly in LA, I suspect. Kyle Schumann is co-founder of After Architecture and assistant professor of architecture at the University of Virginia. Kyle seeks to advance the accessibility of digital fabrication techniques, leveraging democratized technologies in his teaching and research, as well as inventing and building low-cost, ground-up fabrication systems. Kyle holds a Bachelor of Architecture from Cornell University, where he was awarded the William S. Downing Prize for Architectural Design, and he holds a Master of Architecture from Princeton University. where he was awarded the Princeton University Fellowship and served as editor of Pigeon. His professional training includes work at the offices of Todd Williams Billy Sin Architects and Anne Mahayan Winton Architects. Together, Katie and Kyle operate as After Architecture. After Architecture is a design and research studio named to convey the built environment's impact on cultures and ecologies. Their work responds to and confronts the environmental crisis, reframing relationships between biology, technology, and authorship. After Architecture, beyond architecture, before architecture, after architecture. Current projects of After Architecture focus on rapidly renewable biomaterials, including wood, bamboo, grass, various invasive plant species. Their research has been well recognized and supported. So they've been supported by the AIA Upjohn Research Initiative, the Arnold W. Bruner Grant, the Jefferson Trust, the University of Virginia Center for Global Inquiry and Innovation, Virginia Tech's Institute for Creativity, Arts, and Technology, and of course by the University of Tennessee through the Tennessee Architecture Fellowship. After Architecture has been recognized on the list of Curbed Young Guns by Curbed in 2014, named Next Progressives by Architect Magazine in 2019, and included in Cultured Magazine's Young Architects and Designers list in 2021. Their accolades, which are many for such a young practice, include an AIA Central Virginia Merit Award, an AIA Los Angeles Next LA Honor Award, an AIA New England Design Honor Award in Special Projects, a Society of American Registered Architects National Design Award, a Core 77 Design Award in Built Environment, Architecture A+ Award, so on and so on. In fact, I think it was just a couple of days after you guys accepted the fellowship that you won an award and have just been posting great things. For a while, the University of Tennessee was following those accolades around, but now it seems that University of Virginia is following those things around. So I always liken these introductions of fellows to quote from their fellowship proposal, to both embarrass them a little bit, but also to kind of take us back to the moment when they were awarded the fellowship. And in the case of Katie and Kyle, they applied separately, and the committee read through that pretty clearly that these two people are connected. And so we requested that they proceed in the search as a joint applicant. And that was a chance for us to experiment with something that we saw as experimental in the first place, to experiment with the fellowship structure, and to think about what would it mean for someone to hold this jointly. So they were in agreement with that decision, realizing that they would basically take their chances and divide them by two by becoming one applicant. But in the end, it worked out. So Katie wrote, so they had two separate applications, so this is interesting. I'm currently developing an affordable, intelligent, digitally enhanced fabrication system for the evaluation, milling, and joining of structural bamboo at an architectural scale. During the fellowship, I will explore new formal possibilities that emerge from the machine's ability to perform one, visual, non-invasive evaluation through 3D scanning and photographic analysis, and two, the milling of unique joints in structural bamboo building components using a 4-axis rotary CNC. Sorta, right? Kyle wrote, I'm developing a CNC growing system to grow bamboo along predetermined profiles. This project, titled Tooling Bamboo Growth, aims to grow bamboo within a rotating CNC growing apparatus to control the direction of growth. Plant growth will be digitally monitored using photographic analysis to track growth rate and direction so that the system can make adjustments automatically in real time in order to produce structural bamboo in predetermined shapes. In both cases, they were referring to research that they had going at the time in bamboo. But I found each of those quotes interesting in their own way, because you did sort of do that, but not with bamboo. Importantly, they made a decision to focus on invasive species in the area, plant species, that is. But I think a lot of the digital ambition and a lot of the ambition to produce new sorts of assemblies and to think about the environment kind of radically through material development more than through a formal approach has come through in the work. So I'm super excited to have them back. Something that we didn't know would happen for sure, and we didn't know when. But it's my pleasure to introduce Katie and Kyle.
Oh, great. Can everybody hear us? Great. Well, thank you so much for the introduction, Jason. I feel like we have a lot to live up to now, but you'll see hopefully how some of those themes came through in this work, but also I think how it did, like you said, hopefully evolve into its own sort of work that we were able to foster here in Tennessee.
Yeah, yes. I think that was a great introduction, and it is very embarrassing to quote our application. So, so thank you. The digital files never disappear. Keep that in mind. But yeah, we're thrilled to be back here in Knoxville. You know, our year here was such a special time for us, and it's so wonderful to be back in the A&A building with all of you. You know, the kind of pandemic cut short this kind of beautiful time, but it's really great to be able to share the work with you now and see how it's kind of developed and informed our work since as well. We'd especially like to thank our colleagues here for your friendship and support in what was a really formative year for us as academics and individuals. And I would extend that also to our students and the staff. Really, everyone at Tennessee made it such an incredible experience.
We also wanted to specifically thank the students in our Material Misbehavior Studio in fall 2019 for embarking on these investigations with us, and we'll see and hear more about that momentarily. We also want to thank specifically the students in our After Specification seminar from last spring for their material and technological innovations, which were kind of interrupted by the pandemic, but they did an amazing job at sort of adapting to that new situation, as I think all of us did. And we also want to thank the 4 academics who participated in our Authorship in the Anthropocene sort of mini symposium series, which was on March 6th, 2020, sort of right before everything changed for all of us. So our fellowship talk today is structured around 3 intellectual frameworks and 3 tactics covering the work that we just conducted here in Tennessee during our fellowship, and a bit of the work that sort of evolved and emerged and continued since then.
We will begin the talk today with 2 images that set the stage for our thinking about materials, biology, and authorship and the environment, and construct a story through 2 trees and 2 fires.
First, we'll ask you to consider this object on the left, which at first glance seems to be nothing more than the skinned paper-like bark of a birch tree. In fact, it is an object designed and constructed by a human being in the Copper Age over 5,300 years ago. This places it about 1,000 years, a full millennium before Stonehenge. It is a birchbark basket discovered in 1991 with the body of an individual now known to the world as Ötzi the Iceman, on top of a mountain in the Ötztal Valley Alps on the modern-day border of Austria and Italy. Ötzi lived and died around 3400 BCE, and his body and belongings were preserved in the ice before a pair of mountaineers happened upon his thawing body over 5 millennia later. Archaeological evidence deepens this story for us. Inside the bark skin of this basket that you see here, which was sewn together with lime tree fibers, was a layer of maple leaves which provided insulation and enabled Ötzi to carry burning charcoal embers with him. This is a designed object and a piece of human technology that was used to transport fire. It's one that leverages the performative qualities and embodied intelligence of the natural materials from which it is constructed.
The second image we ask you to consider is much more recent. On the right is a photograph taken yesterday by the National Park Service of the largest tree on our planet. This tree, named General Sherman, is 270 feet tall, 36 feet in diameter, and is a single living organism estimated to have been growing for the last 2,700 years. It is currently under threat from the now yearly historic fires in California, and is seen here being wrapped in aluminum foil in what amounts to a seemingly futile attempt to protect it from one of the many threats created by human-induced climate change. This threat is very real to us, as my parents lost their home and nearly their lives in the mudslides resulting from the similar Thomas Fire in California in 2018, and our work seeks to kind of address the issues brought up by these two trees.
The two trees, the ancient birch and the ancient sequoia, are united across time by their interactions with humanity. One is harvested and retooled into the service of containing and transporting fire for us, while the other is threatened by much larger fires that we've collectively created. As we transition to talking a bit about human intelligence, we might consider humanity's impact on the Earth as being tied to our material ethics. The aluminum foil that we just saw being used to protect General Sherman is the product of a standardized industrial processes that have built our contemporary world, but also contributed significantly to damaging our climate. Relative to this, we ask you now to consider two ways to straighten the log.
Since industrialization, the answer has been nearly universal across societies to subtract, to transform the raw arcing forms of trunks and branches, which balance their search for light, water, and structural integrity into a simple orthogonal prism. To break wood down and reassemble it into a uniform and predictable element, producing substantial waste and requiring immense energy in the production of what is essentially a raw material. The intelligence of the grown material is lost, trading greater embodied energy and waste for ease of construction on site. In its earliest days, the Industrial Revolution birthed standards because mass production demanded uniform modes of manufacture regardless of geography. American construction embraced such modes for their ease, speed, and cheapness, and there is perhaps no building product quite so easy and cheap as the humble 2x4, optimized not for a material economy or intelligence, but for human labor, which expanded to encompass an entire range of sequential construction practices and building products.
Beyond industry, standardization practices were embraced by modern architects. In 1931, The Dwelling of Our Time, an exhibition seen here by Lily Reich and Mies van der Rohe, displayed full-scale prototype homes surrounded by displays of the materials and products from which the houses were made, which was sort of contained on this mezzanine surrounding and overlooking the houses. This was a blatant association between industrial materials and modern design, neatly packaged in this public exhibition for a public-facing audience. The tectonics of the more recent digital turn extend and reapply these subtractive methods to now create custom form from standardized materials.
And so today we're going to argue that perhaps more favorable is the approach to straightening a log taken by Alan Wexler in his piece Reframing Nature, in which small incisions are made into the wandering trunk of a tree and wedges are slipped into the mass, redirecting the center line of the tree into a straight path. This additive operation maintains the trunk's taper, its protective skin, its efficient surface area. Wexler's log, leveraging the embodied intelligence of the tree, suggests another question entirely, which is why straighten, which is to say standardize the log. Our work over the last 2 years has taken up this question, introducing biological agency as a framework for shared authorship with non-human agents. And so a kind of example that we like to think of for this is Andy Goldsworthy's work. In this piece, his wandering line of logs leverages their curvature, beginning to address this question. He intuitively systematizes natural materials and phenomena in service of a singular artistic vision, which becomes a collaboration between designer or artist and found grown form.
Conceptions of design authorship in architecture and beyond have historically centered on the primacy of humanity. we're proposing here and through this work a conceptual shift from the authority of the human designer to a discursive and systematic relationship between design intent and ecology that can be enabled or mediated through and by technology. We try to reference individuals and texts that we think sort of relate to these ideas. One such reference for us is Manuel de Landa, and we believe this approach builds off of his definition of active materiality as the characterization of material systems, not just by their properties, but also by their capacities. So asking the material what it can do for you, what you can learn from it, and how it can influence your designs. The recent maturing and increasing economy of technological advances, such as 3D scanning and imaging, tomography, thermography, evolutionary solvers, parametric modeling, et cetera, make data and feedback accessible tools in this collaboration, far beyond traditional digital fabrication techniques. And for us, this enables a kind of kit bashing of technology in which processes are co-opted and aggregated and sort of changed and transformed, which also has a lot to do with the accessibility of these technologies for us. This investigation contributes to the viability of creating alignments between technology and biology that supersede previous morphological and biomimetic approaches.
And so to kind of unpack this approach, we've introduced 3 tactics. And we'll begin with a series of projects falling under Tactic 1, twinned assemblage. Techniques aimed at making digital copies of objects from the physical world have been developing for some time now. Mario Carpo, who coined the term digital doppelgangers, described Frank Gehry's early digitizing practices as a 3D pantograph, in which points are located in 3-dimensional space on a physical object and translated into a digital model. And so the efforts of projects like Gehry's has often been placed on kind of increasing the accuracy, resolution, and overall fidelity of the doppelganger. And as an alternative approach, we're interested in opportunities to reduce and abstract the information captured and stored in the digital model from processes such as 3D scanning, which have kind of matured and become much more accessible. So we're placing a digital lens on the physical world, but also reducing the complexity to contours, center lines, tones, et cetera. And we see this as being kind of in the lineage of architectural drawings, which reduce landscapes to topographic lines, stones to profiles, materials to hatches, et cetera. This is arguing for a kind of selective use of data, similar to Gehry's digitization. Some points or edges are more critical than others in describing the essential qualities of a particular form. And so in this series of projects, we're looking at how we can intentionally distill down digital information and make it influence a design.
So we're looking at how digital doppelgangers, again, can kind of be leveraged or sort of used as part of your design process, both in understanding material and extracting those material properties. And so if we reference maybe traditional authorship models in architecture, we see this as being exercised through a sequencing in which the production of design documents precedes material acquisition and then followed by sort of construction or fabrication by others. And we're trying to examine how a collection of physical parts can be digitally documented, distilled, or analyzed to extract sort of qualities that you're interested in as the designer. So again, you're sort of authoring that technological process. And then how that can be sort of controlled in a digital translation to grant those objects agency within the creation of an aggregate assembly. And so some of the work you see here is from students in our after specification seminar, and in which they curated and then digitized collections of physical artifacts around a specific grouping criteria. So there was, again, a kind of layer of authorship happening there. They then employed a variety of digitization and distillation methods, mostly through Grasshopper, to abstract and reduce these digital models. We're using this term distillation kind of specifically here to describe both an act of reduction and a concentrating of certain qualities. And so we're building on Merriam-Webster's definition of distillation, quote, to extract the essence of. We see these methods as being aimed at kind of 2 goals. One is to reduce file size and computing time, sort of increasing accessibility on that front, perhaps. But also to analyze these inputs to selectively isolate characteristics that inform aggregation methodologies and develop parametric understandings of these meshes according to such biases, which then informs aggregation methods digitally and physically.
So essentially what these studies, which were conducted, after things went online, seek to do is to say, how can we use kind of consumer technology to gain a digital understanding of something and then extract its relevant qualities and input them into a design kind of matrix. And so this was kind of experimented with in various capacities by students. But the kind of larger approach of this work is about thinking as a kind of counterpoint to copy-paste aesthetics that result from specification using BIM, so a kind of tendency towards assembling products repetitively with uniform means. And so instead, we're looking at a workflow that kind of establishes and demonstrates a method for the aggregation of physical parts, where modeling becomes a kind of digital intermediary between the physical object and the physical assemblage. So next, we'll share how some of those ideas also kind of were developed and demonstrated in our material misbehavior studio, which in particular looked at invasive plant species. And so the first project we'll introduce, I think, deals with this kind of quote by Carpo, which is, "The only way to deal with the inherent capriciousness of living materials is to react to their whims and volitions on the spot and on the fly." And similarly, that's a kind of tactic we took in our bamboo-based work before we got here, thinking about how we could make digital means allow us to get opportunistic form rather than to produce irregular form, maybe from a kind of more top-down or aesthetic sensibility. So using the kind of twinned assemblage methodology that we just set up, you can start to construct a relationship between natural material and opportunistic form. And while this approach differs from traditional fabrication methods, the natural material is really becoming a kind of co-author.
And we see this differing, hopefully substantially, we'd like to argue, from these sort of standard or previously standard digital fabrication technologies, in which we're taking sort of raw, irregular materials like wood, transforming those, processing those through subtractive processes into standardized materials, such as dimensional lumber and plywood, and then sort of coming in again as designers and sort of through more subtractive processes, turning that standardized material back into a sort of customized, irregular, or sort of desirable form. And so this project in particular was investigating how this densely branching structure of the burning bush, which is invasive in Tennessee, might be sort of used to construct these sort of forms and these pavilions, like the one that you see here, built by the students. And so they collected, sort of processed, and then documented 8 burning bush sort of fragments or branches that they harvested. They inventoried these and sorted them using photography and sort of measuring and understanding that photography to process, understand the branch, and match limbs with similar branch count and length in order to create this sort of distributed network of these nodes or pieces, which makes for this kind of flexible structure. The whole thing can kind of move and adapt, and they designed this sort of footing system, which ended up being more like feet, that were rounded and could therefore sort of adapt to various topographies, and the pavilion or the architecture could sort of migrate across the ground just outside on campus, right outside the A&A building. So another project from the studio by a different group of students entitled Branching Inventory really delved into a lot of these ideas as well. It was kind of a construction methodology that these 2 students developed, Kevin and Tyler, and demonstrated through a full-scale structural prototype in which they tried to reduce the waste inherent in milling lumber and also celebrate the natural variation of the material, in this case the fallen branches of the, again, invasive Bradford pear tree, and to try to construct a relationship between the grown form of those branches and the final designed form of the installation. And so drawings like this, we refer to as system diagrams, constructing relationships and kind of processes between fabrication, material, computational processes, and then the sort of input or will of the designer became a really critical tool across these these projects for students to really design and think through the process as well as the product of what they were working
And so they take on this kind of question of how the processing of wood into standard components embeds waste and energy into timber construction, and instead takes on the kind of utility of the raw log. And in particular, they kind of analyzed each log by its curvature, by its deviation from a straight line, by its center line, and by its circumference. And these became sorting criteria within a larger assembly, where they created this kind of serpentine surface that had a straight edge and a curved edge, and then this kind of combination of curvature and thickness was used as an ordering principle for these logs or these branches.
And so we see this, this process as hopefully demonstrating a kind of low fidelity, democratized version of other sort of digital fabrication processes. And so they used things like computer or consumer grade scanning apps just on their phones to scan and process this material. All of the material they could just sort of collected from sort of out of nature in and around Knoxville. And then sort of designed and worked through this entire process just in Grasshopper, or what we think equates to industry standard software. And so there's a kind of idea that these processes, while I think complex, are hopefully sort of questioning this relationship again between the designer and the material and the built form, and this kind of authorship that's reworked through those relationships was able to be demonstrated by the students in this sort of large-scale built installation. They also used standard wood and metalworking tools to fabricate the process, and so it was a kind of, in one sense, I think, pretty intelligent sort of digital workflow, but on the other hand, a kind of like lo-fi application of these tools, which we like to think about as in terms of being able to be transferred globally, or in terms of sort of access to larger portions of the population. So our second tactic that we'll get into, also falling under this biological agency or bioagency title perhaps, is growing. And so maybe this is more related to some of Jason's analysis of our applications for the fellowship. But we're looking at collaborating in the last case with harvested natural materials and sort of analyzing those materials and then sort of arriving at forms through various processes. But in this case, we're looking at collaborating directly with living organisms through processes of maintenance, manipulation, and care. And so first we'll get into a series of grown models which were completed throughout 2020. As we began experimenting with the formal potential of non-traditional biomaterials, we started trying to engage with certain agricultural practices and maybe learning from those practices borrowed from other disciplines as much as architectural processes, construction standards, et cetera. And so in this case, we were looking at fodder production, sort of growing this material to use as kind of a food for cows and chickens, rabbits, et cetera. We also looked at work from artists such as Diana Scherer, who engages with growing processes to sort of author these different textiles in a really beautiful way. And so drawing from these as well as other sources, we developed a method for growing these plants, in this case barley seeds, hydroponically into shaped molds. And this process allowed us to create grown volumes and surfaces that self-assemble through the interweaving of growing roots. The forms and textures produced are a mediation between our design intent and the behavior of the barley itself as it sort of collectively behaves. Again, each seed or plant as an individual, but kind of collectively forming these structures. And so through the use of the molds, the barley is taking on these irregular textures and densities as it's growing, which forms for us unanticipated sort of patterning and distribution that might be a bit unpredictable from as a designer or from the sort of overall perspective. And so this behavior, I think, results in these structures like you see here that are sometimes porous, sometimes more solid. They're incredibly complex and varied, maybe more so than we would be able to design or author ourselves. And the roots can also grow through and bind foreign aggregates, such as other grass and wood fibers, sticks and twigs, to create larger assemblies or sort of behave almost as binding agents.
And so our very gracious after specification students were also tasked with playing with these methods in addition to a variety of other kind of experiments. And so they developed a series of different grown forms in order to kind of test what you could do with this process. So on the left, you see a project by Rachel Crosland in which she's developing a kind of literal living hinge, and then a bowl by Watts Brown in which this kind of stepped section actually allowed for kind of an interlocking between two bowls. As well as you see a kind of image on the top right of what it kind of means to make a mold for a growing substance like barley. And that leads to a more recent project that we've been developing with this technique, which is a kind of series of furniture in which we think about really translating this kind of exterior landscape and displacing it from soil, water, and sun, and kind of resituating it in the interior. So the chair is a combination of kind of traditional subtractive techniques in the production of its legs, and what we'll call like kind of grown additive techniques in terms of the way that it's using, again, barley to grow into 3D printed molds. And so here you see a kind of final chair prototype, which is thinking about how you can make something real, grown, but also kind of unnatural in that it's kind of cultivated indoors without soil. It was germinated from seeds and formed without adhesive. And it's kind of about repositioning the relationship between exterior and interior. It's also a kind of co-authorship exercise in that the form is really subject to the pliable whims of each root, which can grow in different directions. So the positioning of the mold also really impacts the positioning of the kind of grain of the grass, which ultimately receives the sitter's posterior.
So we've also recently, again, kind of in this furniture realm, taken on looking at our relationships to plant life in various ways, specifically in relationship to everyday rituals of working and dining and sort of gathering. This maybe took on some new meaning for us in the pandemic when everybody sort of all they had to do was sort of care with their houseplants and curate that sort of backdrop for their Zoom lives. And so this table, Grow On Me, integrates plant life into the everyday ritual. A series of flower pots are nested into cylindrical table legs, giving the illusion that they've been extruded directly to the floor. The round geometry of the legs supports a collection of square tabletops, allowing them to pivot from one another to dislodge the kind of rigidity of traditional seating layouts. So we see this sort of design through this table as supporting a range of activities as its cast of botanical characters influences both the appearance and the experience of the table. Vegetation height, variety, and geometry allow for various scenarios, including foliage, screening, or creating a shared canopy over the kind of occupants. So we might have a cadre of prickly cacti that are allowing for clear visual connections, but keeping coworkers separate. We might have a family of succulents that are joining a dinner party, masquerading perhaps as plates of hors d'oeuvres. We might have a tropical cocktail of banana that are forming a canopy over the length of the table, or leafy monstera that are granting privacy from your neighbors at a cafe. And so in this case, we're thinking about this plant morphology stitching itself together with human social interaction to become part of one symbiotic system and sort of active gathering around the table. And so we've decided in our prototype that you see a photo of here to finish it in this creamy terracotta color and a nod to the materiality of the flower pots that kind of become a formal driver and structural element for the table.
And so this brings us to our final tactic, which is we'll call forming. And the tactic of forming, I think, really comes from a long-term fascination with the Eames, and in particular, a kind of fascination with the contrast between their architecture, which I would say is maybe very much in line with many of the ideas happening at the time, and their furniture, which starts to be kind of entirely custom. Each process of making it has to be invented by them themselves. So they're kind of engaging in this balancing act between specification of kind of these new realm of standardized building products and actually kind of customizing industrial processes themselves to make their own products. And so in this way, we kind of take cues from their, again, lo-fi but inventive approaches that allow them to achieve these kind of various material prototypes, sculptures, and ultimately furniture. The Kazam machine being a kind of emblematic turning point for their practice.
And we see this as being maybe perhaps a question in which we're asking, what would the Eames house be if it were approached instead of this process of specification and sort of invention or use of these new materials in various ways? What would the Eames house be if it were approached with the same kind of level of interest in fabrication and pioneering new technologies as the LCW and the Kazam machine that you see here? And so techniques such as this enabled the Eames to produce sculpture and furniture prototypes, building towards the LCW chair and other chairs that followed, in which form, material, and technology are converging in the production of this iconic design. And so they're not just designing the chair or the object that is very functional and sort of like reinvents this sort of history of ways to sit, but also thinking about, like, what does this material mean? What can we do with it? How can we invent and author the fabrication processes which go into the creation of the object, and perhaps in this case, I think, enable an entirely new type of object, new way of seeing or using that material. And so again, going back to some work from our material misbehavior studio, this project entitled Variable Thickness by Rachel, Gertie, and Rose looked at developing a fabrication process for forming various biomaterial plant elements harvested from invasive species into kind of productive forms. And so this group of 3 students in our studio sort of developed and pioneered a custom reusable forming machine that reduces the waste inherent in creating many complex and varied molds. And so instead of maybe milling foam or sort of cutting a variety of materials to form a mold in which to cast or form a specific geometry, they're using pneumatics and ways to kind of adapt something to the surface to a variety of different geometries. They then used this machine to construct a series of sort of pieces of furniture, and these resultant panels were selectively thin and dense or thick and porous depending on the geometry of the machine, which was kind of designed by them and sort of fed through it, and the distribution of this plant material, in this case an invasive species of bamboo named golden bamboo. And so they're binding this plant material using this forming machine to control the geometry with a bioresin adhesive. The edges of the objects were left intentionally wild, resulting in resisting the clean perimeters common to kind of neatly trimmed or finished off industrially produced materials or products.
And we didn't even ask them to both wear Tennessee shirts in this picture. So these kind of tactics that we've explored will continue on forming, and they really come together in this project that we did at the Knoxville Museum of Art last fall. So the projects and methodologies explored through the studio informed and culminated in this project. And so what this project really tries to address, like much of the other work, is the idea that global construction has kind of favored concrete and steel for their strength and longevity since industrialization, and that we have to kind of unpack those materials and reconsider them due to their embodied carbon and life cycle costs. And so another material we think about and that you see in some of this work is wood, which offers advantages in renewability and carbon sequestration, but limitations in growth cycle, resource availability, and embodied carbon. So Homegrown seeks to advance a body of work that expands the inventory of carbon sequestering grown materials, which we can use in construction, as well as the kind of processes which will allow them to become building products. And in particular, like the other forming projects, we're considering part reduction as a kind of problematic step that we can potentially circumvent. This project is also responsive to the kind of invasive plant species landscape here in Tennessee, and in particular kudzu, which we like as a kind of visual register of a much larger problem. So kudzu is kind of the wildest beast within the invasive species group, but it's also a kind of something that everyone across political parties and across urban and rural regions is familiar with, and can, I think, empathize with the kind of problematic and destructive behaviors of. And so we were interested in kind of engaging with that material through this process.
Mm-hmm. And so transitioning maybe from that sort of wild landscape of kudzu we just saw to maybe a more synthetic landscape, we were looking at sort of, again, different fabrication methods, developing these technologies to sort of think about how we could sort of form a structure using these sort of sustainable methods, again, trying to sort of avoid single-use molds to create custom geometries. And so also drawing from the previous student project, which you saw, we developed this ground-up system, which we're calling pillow forming, in which you can kind of create variable forms through the inflation of a grid of these pneumatic pillows. But you can also create the same geometry and sort of cast or reuse that again and again. And so here you see a kind of test of one of these pillows in which we're trying to calibrate the inflation time to the height of this pillow as we're kind of injecting it with air to determine the height of that part of the surface. And here you see the kind of control system for this. There's a kind of extensive electronic and pneumatic control system that we developed that's run sort of and interfaced directly from Rhino and Grasshopper. And so there's a lot that went in, I think, to the construction of this system. But then in the end, it's essentially what we see as a very kind of user-friendly interface to essentially design a surface in Rhino digitally, and analyze that through Grasshopper, and then kind of with a click or two of a couple buttons, send that geometry in a way that the machine can understand it to create the geometry sort of at full scale with this almost pneumatic kind of robotic air mattress of sorts. And so the pillows were assembled, each measuring about a foot cube, were assembled into a 3-foot by 10-foot long pneumatic forming machine that was mounted on a rigid plywood surface, and so we could essentially create this geometry directly from our Rhino models into the physical world. The tops of the pillows are kind of connected together, so as each one sort of inflates to a specific height, it's sort of maintaining a consistent surface. And we're digitally analyzing a surface modeled by the designer based on its sort of heights, and breaking that down and averaging them. And there's some sort of mathematics happening here to essentially translate the heights and geometries of the surface into inflation times for this grid of pillows. And so here you can see in these series of diagrams the sort of analysis that went into each of these wall panels of homegrown, which we'll talk about more in a second.
So the larger installations form starts with a kind of standard rectilinear room size, the 10-foot interior perimeter, and using a kind of design process, we manipulate a series of curves to create a kind of undulating surface that gives us a contrast between a kind of streamlined, straight exterior and something more kind of bodily in the center. And so this allows us to demonstrate some of the possibilities of the machine in terms of being able to model a complex surface. But it also gives a kind of duality of aesthetic readings, which is further kind of subtracted in order to form things that almost recognizable as windows, doors, etc. So here, Homegrown is seen on display in the Knoxville Museum of Art's South Garden between the stepping pink Tennessee marble facade designed by Edward Larrabee Barnes and the historic brick elevation of the neighboring factory turned condominium building, the Candy Factory, where we actually had the pleasure of living. And so the installation's four walls form an exterior room within the larger walled garden. Homegrown repositions these kind of material aesthetics of digital fabrication, replacing the smooth, crisp machine tectonics synonymous with the digital turn with an architecture that is fuzzy, fluffy, furry, shaggy. Certain dualities emerge. Homegrown is kind of simultaneously primitive and high-tech. It is not permanent, but temporal. The exterior is flat and angular, reflecting maybe more conventional sheet materials, while the interior is undulating, suggesting possibilities for customization or integrated furniture.
Here you see an image sort of looking into and out from one of the sort of primary apertures on Homegrown, again with the sort of flatter, more standard surface on the left and the sort of undulating or rippling fuzzy surface on the right. And viewed as a whole, we see Homegrown as begging a questioning of how buildings are digitally modeled and produced, the materials with they're constructed, and how these materials, means, and methods are able to interact with this ecosystem in which the project is cited. And so we're again referencing the kind of installation as a room here, as exterior room in the courtyard, but also perhaps as an element of the landscape, a hedge or a topiary.
And maybe like some of the grown models, it becomes a kind of composite structure, which includes kudzu, invasive species of bamboo, and then mixed with maybe more traditional forestry waste, timber branches, pine needles as this kind of facing and aggregate. So as a whole, these projects over the last 2 years bridge the process between naturally variable material and design intent, sacrificing some individual design authorship to avoid energy consumption and waste. These projects leverage not just the aesthetic, structural, or behavioral characteristics of biomaterials, but also the physical material itself, and develop a systematic approach to negotiate material intelligence with technology and design intent. The method put forward upends the traditional sequence of design authorship, identifying material capacities in search of an application. Rather than solve the climate crisis or the problem of invasive plant species, the work seeks to suggest methods for negotiating behavior. Behavior as a knowledge model rejects the primacy of knowability in architecture and engineering, so uniform and predictable performance, in a time when we see radical climate events demonstrating that predictability and consistency may be a kind of fool's errand. So we just want to end with that and say that this work is indebted to our incredible time here. Thank you so much to Dean Jason Young, as well as the faculty, staff, and students who made this all possible.
Thank you.
Great, thank you guys. Some questions?
Yeah.
I guess I'm curious about the kind of temporal quality of these artifacts because they're inherently biological. And so I understand the process, but what's the after process? And how does that evolve into something that you can manage or at least grow?
Mhm.
What happens after?
Yeah, and I'm just going to repeat or summarize your question due to the Panopto recording. So you're asking basically what happens to it afterwards, what's the temporary nature, how do you reconcile its like decommissioning or longevity? And I think those are very big questions for us. So we've started with the material and are now kind of developing, trying to make with each step in each project it a little bit more real and to confront maybe more of the aspects of longevity and decommissioning. And so an important thing for us in thinking about aggregates or binders is that we're using binders that can break down without harming the environment through toxic chemicals, which is a challenge based on, you know, a kind of market that's been really emerged around formaldehyde and things like that. But maybe some of the work we are currently doing, you know, after our time at Tennessee is starting to deal with that. So I'm currently doing a project where we're looking at composite grass panels and basically how to make them more dense, last longer, and how do we deal with fireproofing, you know, water and all these things to increase their longevity and their applications.
Yeah, and so we see, I mean, something like the homegrown installation as being like a first step in testing some of those ideas, kind of showing that we can build this thing at maybe an inhabitable scale while maybe still far from a building. It's something that the public can kind of see or touch and understand and interact with. I don't know if it would have looked the same if it were there for a year or two. And maybe off the record, I can say we've lost a couple of the grown models to mice as they were stored in the garage over the winter. But I think we're interested also in, again, like, how does the public perceive of something like this, but also how could we culturally or societally rethink what our expectations are from materials. And so there was a really great lecture by Francis Carey that we saw last semester in which he's talking about ideas of like maintenance and care in architecture and how we might sort of think about the longevity of materials differently, just sort of as a culture. Like maybe it's okay that we have to sort of refinish or sort of care for or maintain material and not necessarily just sort of have something in steel or concrete that we don't have to touch for 100 years. Yeah.
Yeah.
Yeah, I think I can kind of build on that question and even your last comment. Just throughout your presentation, it seems sort of deferential to the plant matters, the biological industry. I was just wondering if you could give any thought to how you might situate these ideas within a sort of sociocultural framework. Particularly, I'm thinking of like indigenous industry have been building in similar sensibilities for a long time. I'm just thinking of is there a given thought to how you might create the relational kind of exchange with individuals as an intention to share? What does that look like? If there's
Yeah, great. So the question is kind of about things like vernacular architecture, indigenous cultures, questions of sort of how these materials have been dealt with or perceived historically maybe. And I think that's something that we're really interested in. Maybe Katie's current grass project that she mentioned is actually planning or working to kind of interface or learn from or engage with a group of the sort of Monacan tribe that's local to Charlottesville, where we're based now. But I think, I mean, I'm interested in always kind of looking at the ways that materials have been used in various contexts. But I think our work is also trying to think about how the way that we interface with those materials could be maybe reimagined, or sort of the way that we think about people engaging with these materials, especially if they're kind of non-designers or the general public, could be thought about differently through these different maybe technological methods. And so like how might we be able to design these processes where the technology is sort of aiding us in understanding or extracting certain qualities from that material? But I think that's a really good question, something that we're going to continue working on, and also kind of always have in the back of our minds. I think it's kind of a very timely question.
Well, I think there's some important aspects to it, which is that, like, essentially many civilizations worked intelligently with grown materials for such a long time, and so much of that knowledge was kind of erased or forgotten with the advent of steel. And now there's a kind of cultural emphasis on concrete and steel. So we found that when we were working with bamboo, that bamboo can make this kind of amazing scaffolding on skyscrapers, but people don't actually want to build the permanent structures out of them, even though there's this long-standing tradition of amazing bamboo craft. So I think part of what we as a discipline have to do is like shift the discussion in terms of like what we value as materials, so that we can learn from those traditions and past techniques, and also think about how new developments allow us to make those techniques economical, right? If we think about the 2x4, it's all about economy. It's about like what you can pick up and what you can lift into place. But as our world changes, there's new ways to engage different processes that weren't viable economically in the past.
Yeah, and relative to that, I think part of what we see in the 2x4 is its knowability in terms of like codification and incorporation into kind of standardized building and predictable structural performance. And so one of the issues is that with all of these kind of non-standard methods we're looking at, there doesn't really exist ways to kind of predict their structural performance, and kind of there's not that element of knowability of like, what is a 2x4 going to do performatively for me? And so this is something that Mario Carpo writes about a lot in terms of new digital simulation and sort of the advancement of that relative to heterogeneous sort of structures and things that could become somewhat predictable, even though they're sort of far from the sort of standardization of something like the 2x4.
Yeah, it's super interesting because it gets multidisciplinary very, very quickly. Yeah, I see another hand.
Yeah, so it's a great question, I think, about like synergies between the types of material palettes that we're looking at versus like other advancements in material science, like nanotechnologies, graphene, all those sorts of things. And I think something interesting that we've found kind of delving into this world of maybe non-traditional biomaterials is that a lot of the experimentation and really interesting things going on are coming from disciplines that are maybe not really in material science and not really in like architecture, but more in like fashion design and product design and maybe furniture. Like I think which are maybe design fields which are sort of much quicker in terms of the time span that you need to kind of produce a work versus the construction of a building. And so we're really interested in sort of looking to those fields to kind of learn from them and sort of learn with that sort of speed of, I think, material investigation. But we also see maybe synergies, I think, relative to that question in terms of the technologies that we're using to look at biomaterials. And so I think there's lots of really interesting work being done here and elsewhere, looking at things like carbon fiber, looking at like 3D printing, various materials in new ways. And I think we're interested in what are the technologies that are being used to work with those materials, and how might we take some of those technologies together maybe with some different sort of scanning and machine visioning ideas to process these irregular materials and sort of feed those potentially through like similar parallel workflows, or at least methods that kind of learn from the rich investigations being done sort of today and yesterday and tomorrow with these other materials that aren't necessarily grown or harvested from your backyard.
Yeah, well, I mean, architecture, maybe as we all know, is an interesting problem in terms of shifting tastes or convincing clients about the unknown. You know, it's much easier to get a new chair adopted than a new building system, and part of it is a kind of risk aversion, to property value and longevity and all those things that make a lot of sense. But yeah, because of that, it's been useful for us to try to work at multiple scales, but also to look at, other people working in this space who I think have been able to scale to quite incredible sizes. So, a lot of those projects come with the kind of small scale prototyping first. And I think that's kind of our strategy right now, is to prototype things, get them off the ground, and then develop them in a way that they could be implemented on larger projects. But I don't know, maybe that's not a super concise answer.
Well, no, that's great. I think part of it too about, I love this question about the agency of the prototype, because I think that's sort of how we approached the Material Misbehavior Studio and those installations that you saw here, and that we were encouraging or kind of requiring students to, while it's still a small or modest scale compared to a building, I think it's important that we saw them all as full-scale investigations or full-scale prototypes that you can kind of walk around or walk under or walk through or touch and interact with. And I think that's important for us in terms of thinking about forming this larger sort of strain of research of like material investigation, and then thinking about ways to kind of scale that up. And so just in terms of the kind of metrics or ways that work is sort of generating interest and then allows us to pursue other funding to kind of scale up in the longer term. We were thrilled when a couple of projects from that studio were featured in an article in Architect magazine, so there's like some interest from kind of the professional perspective, and we're also mentioned in a blurb in the New York Times sort of by this reporter, which I think was important for us because it indicates interest in the ideas, or sort of the public is able to see a value in a full-scale prototype, even though it's sort of a very small, modest scale, which we see as an important first step in kind of shifting that conversation that Katie's talking about relative to sort of what are perceptions of these materials, how might you sort of begin to enter or adapt or sort of shift that cultural imagination when somebody can just see something built at full scale. And so it's important to us, again, that the prototype is, while small, I think the differentiation or the fact that it's full scale, however modest that scale may be, was really critical for us. And again, granting that prototype some sort of agency to sort of enter the imagination of the viewer.
Excellent. Yeah, so thank you very much for the lecture and engaging the questions here. Really appreciate that you guys came back. And the fellowship model in the discipline is something that they've thought a lot about, and they've organized last January, February, national kind of survey of fellows, and I think it's interesting if kudzu, as you said, is a visual indicator of a much larger problem. It's interesting to think about what invasive species are indicative of in a much larger sense, and maybe even what research at the level of fellowship is indicative of much larger, not problems, let's say, but opportunities. And I think that you've really set the stage for yourself here with what you're doing. So thank you very much. Thank you guys for coming out.
Thank you.
Thank you. Forgot to mention, yeah.